Okay, so in this webinar session, we are going to look at how we can replace the legacy ETL and the enterprise data warehouses with open source solution. Right. So in this session, we will be talking about the complete data pipeline. Okay, so it will be the complete data platform that will be basically having the walkthrough of. Okay, so without wasting much time on the introduction part, let's deep dive on the next part. Okay, so we have a very simple timeline over here, right? We'll spend some time on the architecture slides and then we'll jump directly to the demo presentation. Okay, so let's start with the definition of the data lake. Okay, so what is data lake house? Okay, so to understand this concept, we can take an example of maybe a physical storage warehouse. Okay, imagine you have a bigger and cheaper data warehouse. Okay, in which you like dump all your boxes inside. Okay, and then uh, basically it is not going to basically store basically, even if it's a cost of pennies to store the things over there in the that cheap warehouse, but at later time if you have to find something, okay, it's going to basically become a headache. Okay, so now imagine putting a smart manager inside that warehouse. Okay, who basically exact second you ask for something to that manager, okay, he runs, grabs it, and gives it to you. So basically, the concept behind the data lake house is when you merge two things. First is the fast database and the cheap data lake. Okay, so data lake house is basically the smart system that merges the best features of the fast databases and cheap data lakes. Okay, it provides you the 100% operation freedom. That is zero platform locking. What is zero platform locking? Meaning that if tomorrow, if you want to switch between the any other tool, okay, so if tomorrow a new tool came in which is much better than the one that you're already using, you can just swap with that old one. Also, you can integrate the whole pipeline. Like suppose you have one real-time pipeline that you can integrate with the industry standards like Apache, Iceberg, and Trino. Right. So basically, if you are tracking the terms like Apache, Iceberg, Medellin architecture, and the Trino, right? So and you want to see how this all clicks together in the real-world pipeline, right? Then you are at the right place. So in the next slide, we have few challenges with the enterprise data warehouses and the legacy ETL tools. Let's discuss these pain points with the help of this legacy system architecture, in which the Informatica Power Central is being used. This is one of the basically use case, but we can basically consider it with the multiple enterprise platform as well. Okay, now if we talk about this one, this is the standard ETL setup in which we have, suppose you have one application, okay, online application that dumps the transaction directly into the database. Okay, and then there are some remote store as well, which are basically uploading the uh, daily point of sale transaction into a particular folder. Now your Informatica Power Center ETL tool process the data, apply the transformation, and loads it into the uh, costly data warehouses. Right. So this whole pipeline looks good at first, right? But as soon as the volume of data scales up, the whole thing starts lagging. Your pipeline starts running slow, right? Along with that, the compute cost of the whole system, right, started increasing. Also, you will have to pay for the hundreds of dollars, uh, just for the license of the particular software, right? So, along with that, there are other things like suppose you want to upgrade it to the uh, next version, right? In that case also you will have to hire a consultant, so that cost also you will have to bear. So in the next slide we have this modern data lake architecture. So this is the same setup. The only thing is over here, uh, we have all the open source tools integrated over here, okay, in which the source systems and the destination are same as per the whatever the legacy architecture that we were having earlier. Okay, the main thing over here is basically this whole architecture can be integrated with the n number of sources as well as the one n number of destinations. Right. So currently in this architecture, we are pulling the data from the database and the store paths, basically folders. So we have different layers over here. As you can see, we have the ingestion layer first, in which we have the Apache NiFi cluster. So Apache NiFi cluster basically validates the data. Okay, once it pulls it from the database and the folders, it validates it. If the data is valid, it will directly push into the bronze bucket into the MinIO S3 storage system. If the data is not valid, if there is any corruption or maybe the schema validation is failed, okay, then in that case it will push directly into the MinIO DLQ bucket. Now, whatever data that we pushed into the bronze layer, that data is raw data itself. We have not done any transformation over it. We have just validated it in NiFi. Now, at storage layer, we have two things: Apache Iceberg plus MinIO. MinIO is a S3 compatible storage system. Okay, and Apache Iceberg. Now, what is Apache Iceberg? Apache Iceberg is the component that makes the storage system behaves like an enterprise data warehouse. So there are multiple features of the Apache Iceberg. This provides open table format specification, allows the data to write into the open table format, so can be read through the multiple components like multiple query engines and compute engines as well, right? Like Spark, Trino, etc. Apache Iceberg basically also provides like many other things. Like the first one is ACID transaction, so it gives the full ACID guarantees, right? So that's to prevent the basically if there is a corruption, if there are two processes that are running simultaneously to write into the same row maybe, okay, in that case Apache Iceberg handles it in a very optimistic way. Another thing is it also tracks the basically historical snapshot versions. So uh, because of which it can allow us to basically do a time travel query on the tables on the data that we have. So we can view what data it was there, maybe the last 1 year ago, 2 year ago, or maybe last month, what was the data in the Apache Iceberg table. Okay, so those query we can do using a simple SQL query. Okay, so that's a major advantage in Apache Iceberg. Also, not just basically tracking the data, okay, not basically just tracking the uh, past data, we can roll back to those previous data as well. Okay, so that is also one of the major feature of the Apache Iceberg. We'll have a one small session on this one. We'll have one example to view all these features, okay, at the end of the session. Now, moving to these layers, we can see that there are bronze layer, silver layer, and gold layer. What are these? So these all layers, all three layers all together are known as the Mendelian architecture pattern. In the bronze layer, it holds the raw data, so there was no any transformation over this one. But once the data moves into the silver layer, all data get transformed, aggregated, filtered, deduplicated, and then pushed into the silver layer. And further, this re-aggregated to the gold layer. In the gold layer, we have the data that is tailored to the business reporting. And in the silver layer, we have the aggregated and transformed data from the raw data. And all these transformations, aggregation, all are done through the Spark jobs. Now, where are these Spark jobs running? So we have orchestration layer over here, in which we are using the Kestra tool. The Kestra is responsible for scheduling the Spark jobs based on the events. So as soon as the NiFi pushes the data into the MinIO, it sends a trigger to the Kestra, and Kestra will send basically schedule these jobs one by one. Moving further, we have the query and the service layer, where we have Apache Trino and Apache Superset. Now, the Trino is the query engine which allows us to query the data from the Apache Iceberg over here in our case. And the Apache Superset is a tool for the dashboard. Okay, so we have integrated it with the Apache Trino to view the data in the form of charts. Okay, on the dashboard. Apart from that, we have other tools which are very crucial. So like for the governance and security, we have Apache Polaris for the metadata and the catalog management. Then for Apache Ranger for the basically authorization part to enforce the policy on the users, right? So which user has right to which user has access to write the data into the Apache Iceberg, which user has access to read the query from the Apache Iceberg, right? So all the policies can be applied through the Apache Ranger UI. Apart from that, we have a lineage tool, right? That is Apache Atlas, which can allows us to view the lineage of the data from each tool. So we'll be having a basically demo on that one as well, how the data is moving through each component. At the end, we have the Prometheus and Grafana for the monitoring and observability. So which shows us the basically details of the CPU, RAM, and other system related resources of all the services. Moving further on the next slide, we have the differences between the enterprise and open source data lakehouse. After this slide, we'll go jump to the walkthrough session of the whole architecture. So in this comparison, we have already discussed the costing part, but just to add on, so in open source, we can download the software for the $0, right? We don't have to pay for the server, storage, anything. But in terms of when we use the enterprise version, we'll have to pay for the servers, we'll have to pay the storage, also we'll have to pay for the subscription as well. When we use the open source tool, we have full control over the data. So in open source, we basically write the data in our own digital hard drive. So maybe tomorrow, if I my mind is changed to use some other tool, right? Then my data will stay there as it is. But in terms of enterprise, when you want to switch to maybe some other competitor tool, right? In that case, those they make it very like complicated and expensive as well. So it's not easy to get your data back. When we use open source, you have a full like access to the source code. Engineers can see every single line of code. They can make changes to as per their need. They can fix the bugs by themselves, right? Those all things are possible in open source. But if you face any issue in the enterprise, okay, if you face any bug, right, you will have to raise the customer support ticket. Also, if you want any feature, right, in that case also you'll have to raise the support ticket and you'll have to wait for the months to get it resolved. Also, apart from that, we have this stack design in which we can say, suppose you're using Apache Iceberg, you are using Trino for query, you are using MinIO for the storage. Okay, maybe tomorrow any new tool came in, right? Just swap it with that one piece of tool, right? You don't have to keep stick to that one tool. And in enterprise, they will force you to buy their all the tools, right? Even if you don't want all of them, right? They will force you to basically buy database tool. They will force you to buy the dashboard, a monitoring tool, security tool. All those tools you will have to buy. And the last one is the development. So basically, engineers from the top companies are continuously working to make this open source tools safer and faster day by day. But when we talk about the enterprise, right, the team of a company that owns that particular software only improves that software, right? And that is also uh, basically related to their goals of like business goals only. So yeah, so these are all the basic comparison between the enterprise and open source data lakehouse. Going further, I'm jumping to the demo part. Okay, so as we have seen in the architecture, in the ingestion layer, we have an NiFi. So in NiFi, this is the NiFi UI. Okay, in this NiFi UI, we have two process groups. These are the two flows. So data ingestion from the offline stores and data ingestion from the online stores. online database. Okay. So offline stores reads the data from the particular folder, validates and pushes further in the bronze bucket. If the data is not valid, it will push into the DLQ. Another flow that we have is data ingestion from the database, in which we are pulling the data from the database tables. Okay, we are categorizing based on the order date and pushing into the bronze layer. There is no any transformation we have done on the content of the data. Okay, so what we'll do, I have already opened MinIO here. Okay, this is the basically you have the MinIO. Okay, in which I have created two buckets. One is the DLQ, which stores the invalid data, and the another one is the Shopcat Lakehouse, which has this bronze folder in which we already have categorized, added few like data in offline as well as the online as well. We can see the data is categorized in the date-wise format. Okay, so and then this is Kestra UI, in which I had run a few jobs earlier. Okay, we can see that. So if I open this one of them, right, so it shows us two jobs over here: execute bronze to silver and the silver to gold. So these are the Spark jobs, which Kestra triggers automatically when the any particular file arrives in MinIO. And then we have Atlas, where we'll see basically whole lineage of the data over here. And then we have a Superset dashboard, and then we have Ranger and other things as well. Okay, let's jump to the demo part. Okay, what I'm going to do is I'm going to push some data into the source database. Okay, so we have the source database over here, right? So currently, as you can see, there is no data being pulled in right now. Okay, so it's everything is 0000, right? So let me zoom in a bit. Okay, so no in, no out, nothing is being pulled right now, so no data is being pushed. Okay, so moving further, I have some data already. Good. Let me refresh this. Okay, now I can see that there is a one record like has been pulled from the database itself. Okay, pushed further into the bronze layer. Okay, so since this has already pushed into the bronze layer, let's check over here in the MinIO. Okay, it's the same place. This is date 10 July. Right. Right. Yeah, this is the one with the latest one. Okay, now you should be able to see a job running in the Kestra as well. Okay, let's refresh this one. So right now it's three. Let me refresh this. Yes, there is one already in running state. Let me open this one. Okay, let me go to the Gantt. Yes. Okay, I can see these two jobs over running over here. The one is already completed, the bronze to silver. The other one is running. Okay. Meanwhile, let's see to Atlas. Let's check if there are any lineage created over here. Yes. Okay. So we can now see there are some entities created in the Atlas as well. Let's wait for the this Kestra to finish the Spark jobs. Okay. So it's about to finish. Yes, this is also done. Now to go back to the Atlas to view the lineage. Okay. What I'll do, I'll just click on anywhere, any maybe let's check this one, and here in the second tab we have the lineage. Okay. Okay, to view to the whole lineage, okay, I'll just go here, go to the click here, or I can basically change the depth as well. Okay, so this is the first processor in the NiFi itself. Okay, let me go back to the NiFi to show it. Okay, we have this first processor over here, okay, which pulled the data. The same thing I can see over here, right? I can see the NiFi NiFi qualified name as well over here, right? And then moving further, okay, so it is pushing into the this MinIO, right? So here we can see this is the NiFi processor, put MinIO bronze layer, okay, and it is pushing into this S3 bucket. This is the location of the S3 bucket. We can see over here, and after that there is a one job that got executed, right? That is the uh, basically bronze to silver, right? Okay, let me change the depth here, okay, so that we can view the silver to gold as well. Okay, so this is the first job which has two operations. One is the filter, second one is the write operation, and then sales unified table that got created in the Apache Iceberg. Okay, so this is the Iceberg location, and then we have the another job, silver to gold. This is the Spark uh, URL here, and then we got this another table in the Spark, basically in the Iceberg table, okay, inside MinIO. So these both the tables are having the Iceberg table format and stored inside the MinIO object storage, right? So to view that, what we can do, I can go back to here in the DB itself. So here we have the daily sales summary and the sales unified as well. And to check what is the exact data that got pushed, right? So we have Superset dashboard created over here. So this is already, I think, updated, right? Yes, no. Oh. So we have refreshed this. It got updated with the latest data that we just pushed. Right? So inside this superset, what we have done is we have integrated the superset with the Trino. Okay. So to check that, what we can do here in the settings, we have this database connection over here. There you can see the Trino connection was made, was created earlier. Okay, to connect with the Trino DB to query the data from the Apache Iceberg tables. Okay, so here is the basically URL of that Iceberg catalog. Okay, before moving to the next part of this session is the to check how the time travel works. I want to show you on the Ranger level. Okay, so this is the Ranger UI. Okay, let me log in with the user. So this user is coming from ALDAP. Okay, so we have integrated ALDAP to pull all the users into the Rangers. Only those users which are there in the ALDAP will be able to log in. Okay, and we have created two services over here: the Spark services and Trino service. Okay, so this service allows us to basically enforce the policies on the specific users, which users will be able to write the data and which users will be able to read the data. Okay, those policies we can uh, integrate from here. Okay, now moving further to the time travel demo. Okay, so let me go to the editor. Okay, okay, so I have this whole setup for this demo, in which I have already created the customer event, which has three columns: event ID, user ID, account tire. Okay. So if I want to check what is there inside this table right now, just a second. Okay. Okay. So as I have created inside this table, there is nothing right now. Okay. So what I'm going to do, I'm going to insert few records. Okay. So there are three records that I'm going to insert. Okay. E1, E2, E3. Okay, with the enterprise free and enterprise uh, account tire. Okay, so let's check total records in the customer events table. Okay, so as we can see, the three records are there right now in this table. Okay, now the next part I'm going to do is to delete the data from this table. Okay, we have three records already. I'm going to delete some data, okay, based on the enterprise. So we have account tire column inside this table, and I'm going to delete based on this enterprise, right? So there are two records with the enterprise. So once I delete this, there will be the expected is the one record, right? Deletion is done. Let me check the data. Yes, now I can see there is only one record, okay, in the customer events. Now we are going to run a time travel query. Okay, before that, what I will do, I'll check what are the snapshots that was taken by the Iceberg, okay, for this table operations. So this is the query I'm running on the customer events table. Okay, I can see that there are three events. The first one was for the table creation. Second one was for insertion of the data. Third one is for the deletion of the data. Now, what I want to do is I want to view the data which was there before deleting the records. Okay, so currently if I check inside this table, there is only one record, but I want to see the all three records which were there earlier before deleting. Right? So what I'll do, let me go back to the snapshot again. I can see the timestamp over here, right? At committed, right? Let me copy this one. Okay, and I'll change this little bit. Maybe I'll just say, oh, so I want to check the state of the data before the deletion. Running this query, now I can see all three records which were there earlier before the deletion. Okay. Okay. Now, one more major advantage of this one is basically even we are here, we are just able to view the data, past data, right? But I want to make this table as it is when it was there before the deletion, right? So for that, what I can do, I'll just go back again to this snapshots. I'll just copy this snapshot ID. Let me go back and check again. Yes. So here we can see that all the data which was there before the deletion got restored again. Right. So this is the major advantage of basically having the iceberg in our whole architecture. So that concludes the session. Okay. So that's it. It's all about the what we had for the this data lake session.